Hello and welcome to the lesson on nonlinear regression. So the goal today that you can identify first of all that it's a nonlinear correlation, so you can look at the scatter plot and then you can determine what type of nonlinear correlation it's going to be, and you're using the graphing calculator to do this. So the reason I do this isn't technically part of the curriculum, it's kind of alluded to. The big thing is when we look at your results from your project, not all data is going to be linear. It's just not the way the world works. So to make it easier for you to do your analysis, I'm just going to show you the nonlinear, and you're going to find not a big difference in terms of linear versus nonlinear. So looking at the types of nonlinear curves, I'm just going to give you a couple of the common ones. So for nonlinear curves, you're going to have, if you find one that looks like this, for example, and you're going to find one that looks very, very similar. If it seems to be more of a gradual increase, this is our quadratic curve. So same as it was in grade 10 and 11 math, so a quadratic or a parabola. If it seems to be a lot steeper, or if you try the quadratic and it doesn't work, the next common one I would look at is an exponential. So what I would be doing is I'd be putting some of these curves on your cheat sheet to help you out if you can't remember them, just the general shapes, because you're going to have all these options in the graphing calculator to pick from. So we have quadratic, we have exponential. If you get a funny curve that looks like this, we call this cubic, a cubic curve. If you get a repetitive curve, or cyclic, if you remember from grade 11, this is a sinusoidal or a sinusoidal curve. Okay, so when you get that wave, there's a couple other ones a little bit less common. If you find a W shape, either an M shape upside down, this could be a quartic. Not as common. I'm trying to think. I think that pretty much covers the majority of them. And if you look at your graphing calculator and you hit the stat button, and went to sleep on me, hit the stat button, and I look at calculate, you'll see they're all there. So there's the line, the linear one that we just finished 2 days on. Then you have quadratic regression, cubic, quartic. We don't have to worry about number 8 in this course. Logarithmic regression, that one, it might be possible if you see a curve that looks like this, a parabola on its side, that might be one of the options. Now I know you guys haven't talked about logarithms at all, so that one I'm going to try to avoid, but if some of the data comes up that way, it's what it does. It comes up, so you can't do much about it. What else we got? We got exponential and a power one. So for us, I'm just more worried about the exponential. You don't need to worry about the power one. And that's about, yeah, there's your sinusoidal regression at the bottom. All right. So they're all there. So it's just a matter of identifying the curve that's you're presented with in the data. Okay. So moving on, just talking about the correlation and how it's calculated. So from our linear regression, I showed you what the equation was, and for linear regression or correlation, we use R. Okay? When you are dealing with a nonlinear relationship, we have to use the coefficient of determination. All right? So it's not the coefficient of correlation anymore. It's the coefficient of determination. Now, in the end, you're going to be like me. It's too much to say because it's a mouthful. I say what was the R value or what was the R squared value. It's just make sure on your cheat sheet that you put down R coefficient of correlation, R squared coefficient of determination, so you can differentiate between the two. But R squared is what you use for curves. So again, people are looking at the formula, keeping their fingers crossed they never have to apply it, and that's exactly correct. I'm not going to make you apply it. I'll show you where it comes from, though, quickly with the scatter plot I have here. The calculator is looking for a curve that fits in here, and the R squared, how it's measured, what happens is that they find a mean or mean of the Y. So these are your Y values. So we're looking for that mean value. So I'll just draw it across here. So the mean value, the average Y value, and what it's doing, it's calculating the distance from this point here and this point here. All right, so what they call this the unexplained difference. And then the one that's below the line is the explained difference. And that's what they do for every point. So the curve it generates, the calculator, it's continually calculating that distance there. So where's another example here? It's easy to draw for me. So this one here, down here, there's the explained difference. And then this is the unexplained difference. It then gets put into this formula, and this is the sum of the explained variation, sum of squares explained, and then this is the sum of the total variation. All right, and as I said, you do not need to put this formula on your cheat sheet because I will not be making you use it. Just wanted to do a very brief version. This is obviously I changed the terminology with this as well, just because there's just no sense going into it when you have the technology now that handles it for you. So anyhow, there is the summary as to where that formula comes from. All right. So at this point, I am going to leave it, and I will do the examples in the next video.